A million miles from Earth, a machine the size of a tennis court is staring into pure darkness. It has been up there just 3 years, and it has already caught the universe breaking its own rules. Stay to the end, because the last thing I will show you genuinely should not exist. This is the story of the most powerful eye humanity has ever built. Let's go. So how do you photograph the beginning of time? First, you build the most extreme camera in history. Its heart is a giant golden eye. 21 feet of mirror, 18 hexagons, each one coated in real gold. That eye drinks in 6 times more light than Hubble. It could spot a single bumblebee sitting on the moon. But here's its real superpower. Webb doesn't see light the way you do. It sees heat, infrared, so it looks straight through the dust clouds that blind every other telescope. Why gold? Because for infrared light, gold is nearly a perfect mirror, and the entire coating on that giant eye weighs about as much as a golf ball. There's a catch, though. To see faint heat, the telescope itself has to be brutally cold, minus 370 degrees, colder than Pluto. So it hides behind a 5-layer sunshield the size of a tennis court, a million miles from home, and if anything broke out there, nobody could ever come fix it. And getting it there? The telescope was too big for any rocket on Earth. So engineers folded it up like origami and prayed. What followed were the scariest weeks in NASA's history. 344 single points of failure, unfolding one by one, a million miles beyond help. Every single one worked. Then in July 2022, Webb finally opened its eye, and the first pictures stopped the world. This is not a mountain range at sunset. These are the cosmic cliffs, a wall of gas and dust several light years tall, where stars are being born as you watch. And when astronomers zoomed in, they froze. Hidden inside those clouds were hundreds of newborn stars that every telescope before had completely missed. Hundreds of suns hiding in one photo. See those tiny jets? That's what a star looks like in its very first moments, screaming beams of gas as it switches on. And the colors aren't decoration. Each hue is a different gas, so this isn't just a photo. It's a chemical map of a stellar nursery. Astronomers even rebuilt these cliffs in 3 dimensions and found giant caverns inside, carved out by winds from monster stars just outside the frame. Think about that. Starlight so fierce it sculpts mountains of gas. That's what's shaping everything you're looking at. Next, Webb aimed at the most famous photograph in astronomy and made it look brand new. The pillars of creation, towers of cold gas, trillions of miles tall. Hubble made them a legend back in 1995, but Hubble only ever saw the outside. In infrared, the dust turns to glass. Those glowing red dots at the fingertips, baby stars caught at the exact moment they ignite. Hubble saw the postcard. Webb sees the delivery room inside it. But here's the dark twist. The pillars are being destroyed by the very stars they create. A nursery, demolishing itself as it gives birth. And since this scene sits 7,000 light years away, there's a real chance the pillars are already gone. We may be looking at a ghost. But Webb's greatest trick isn't seeing far, it's seeing back. In time. This is the deepest infrared image of the universe ever taken. And the patch of sky it covers, the size of a grain of sand held at arm's length. 1 grain of sand, thousands of galaxies. Almost every dot you can see is an entire galaxy. Hundreds of billions of stars each, and that glowing cluster in the middle is bending space itself. Einstein predicted that bending a century ago. Webb just uses it as a free zoom lens built into the universe. Remember, light takes time to travel, so looking deep into space is looking deep into the past, almost all the way back to the very first stars. Some of these galaxies sent their light more than 13 billion years ago, when the universe was a toddler, just a few 100 million years old. And Webb grabbed all of this in hours. Any telescope before it would have stared for weeks and seen nothing. Hold on to that thought, because those baby galaxies are hiding a problem we'll come back to. First, Webb learned a trick that feels like pure science fiction: reading the air of alien worlds. That's right, Webb can analyze the atmosphere of planets it can't even photograph properly. Here's how. When a planet crosses its star, a whisper of starlight leaks through its atmosphere. And every gas, water, carbon dioxide, methane, leaves its own fingerprint in that light. No sci-fi scanners, just light, patience, and brutal math. Using that trick, Webb made history, the first clear detection of carbon dioxide on a world outside our solar system. That world is WASP-39b, a puffed-up gas giant hotter than an oven, racing around its star once every 4 days. Reading air this way is like tasting a single drop and describing the whole ocean it came from. Webb does it routinely. On other worlds, it has spotted water vapor, high clouds, and on one planet, clouds that seem to be made of sand. And right now, it's scanning 7 rocky, Earth-sized worlds around a tiny star called TRAPPIST-1. This is the first real hunt for a second Earth. Because one day in the air of some quiet little planet, this exact trick could find the unmistakable breath of life. And here's the pattern Webb keeps stumbling into. Everywhere it looks, it finds the ingredients for life. In the cold dark between stars, complex carbon molecules, the same chemistry your own body is built from. Around newborn stars, water, not somewhere exotic, right in the disks where planets are about to form. Sitting exactly in the zone where rocky worlds like Earth take shape, water, waiting for planets to happen. The same molecules turn up on asteroids and comets, the delivery trucks that may have watered the young Earth. Which hints at something huge. Oceans might not be a lucky accident. They might be standard equipment. Water, carbon, energy. Over and over, the universe hands out the starter kit for life. Whether anyone out there ever opened the box, that's the question. For all that power, Webb also looked back at our own neighborhood, and even home looked brand new. It caught Neptune's ghostly rings, the clearest view since a lone spacecraft flew past more than 30 years ago. First time in 33 years. It watched auroras dance over Jupiter's poles, northern lights big enough to swallow the whole Earth. It even caught Jupiter's thin rings, normally drowned out by the planet's glare, all in a single stunning shot. It watched clouds drift over Titan, Saturn's strange moon with rivers and seas of liquid methane. Mars, Saturn, distant comets, all mapped from 1,000,000 miles away by the same machine that reads the edge of time. And now it's time for the problem I promised you. Because out at that edge of time, Webb found things that should not be there. Remember those baby galaxies from the deep field? Here's where they break everything. Some of those early galaxies are far too big and far too bright for how young the universe was. It's like opening baby photos and finding fully grown adults staring back. They shouldn't be there. They don't break physics itself, but they do mean our story of how galaxies grow is missing a chapter, maybe a big one. And it keeps happening. The deeper Webb looks, the more of these impossible galaxies it finds. This isn't a glitch, it's a pattern. The current record holder sent its light when the universe was barely 300 million years old. That light traveled over 13 billion years to land on that golden mirror. One telescope. And astronomers are rewriting the origin story of everything. That almost never happens in science. And it gets stranger. Webb went hunting for the monsters at the hearts of those galaxies. It found supermassive black holes, millions of times heavier than our sun, sitting in the early universe where they've had no time to grow. Too big, too early. One of them was already feeding just 400 million years after the Big Bang. Our old theories simply cannot build a monster that fast. Maybe they were born huge. Maybe they grew in ways we've never seen. Right now, nobody knows. And that's the real gift that this telescope keeps giving us. Not just answers, better questions. So that's 3 years of one telescope, newborn stars, alien skies, and galaxies that refuse to follow the rules. Webb has fuel for many years to come, and honestly, it's just warming up. Subscribe, because the next picture might rewrite the story again.